Welcome back, dear students. So today we are going to start with the most awaited chapter. I had got many children asking me, when are you going to start chapter 1 of electronics paper 1? And so here we are. There was a reason why this chapter is kept to the end, because there are many things you will not understand if this chapter was taken first. So that is the reason this chapter is taken towards the end. Every year we do that. In most of the colleges we do that. So here we are starting with chapter 1 of electronics paper 1, sources of electrical power and network theorems. So let's move ahead with this. Starting in this chapter, you need to remember that the first half of the chapter is like dependent on basics. Okay, it's completely dependent on certain basics. Like if you've done your class 9-10 physics properly, you would easily understand the basics. So what is a basic of electronics? That is electronics. That basic is electricity. Okay, so flow of electrons. Fine. So related to that, the first concept is electric path. Any conductor, okay, any conductor which can allow flow of electrons in a complete closed path, then that is known as an electric circuit, a closed circuit, right? So it can be defined as the path of current. So here you can see this. When the switch is off, the bulb is not glowing. Okay, when the switch is closed, you see this on off button as well. When it is on, the circuit is complete and the bulb will glow. Basic physics, right? When there is a closed conducting path, then electrons can flow, and obviously in the presence of a battery or a cell, it will provide the charge and flow of current will happen and the bulb will glow. Okay, so that is electric circuit. Okay, so what is charge then? So किसमें measure करेंगे हम electricity? Yeah, you have to measure electricity in something. So that measure, that quantity of electricity is known as electric charge. Okay, and what is the unit of charge? It is measured in coulombs. In coulomb, C, coulomb. So what can a coulomb can be defined as the how much quantity of electricity is passing a given point when 1 ampere current is maintained for 1 second. Okay? When 1 ampere of current through the closed circuit, this current is flowing, right? So how much electricity or how much quantity is there of electricity when 1 ampere of current is passed for 1 second? That is the definition of coulomb. Okay, so we'll see some nomenclatures or some basic keywords. Electric circuit, we have already seen. A closed path is known as electric circuit. Electricity, that is what is flowing in this, right? That is electricity, basic electricity. So it's then, what is that? It is, can you see electricity? I would say you cannot see electricity, but you can feel electricity by various equipments like the fan, the tube light, LED, right? If electricity is gone, you cannot actually feel the presence of these things. But that is directly not, that's a device. That is not electricity. You chal raha hai electricity pe. So can I say that it is an invisible force? Yes, I can. I can say that electricity is an invisible force. And what all can it produce? It can produce heat, light, motion, many other things. Motion, for example, a fan. जब electricity on होता है, the fan, if it's connected to an electric point, then it will move. So motion, heat, आपके electric heaters, या even bulbs, बहुत देर तक अगर चालू है तो light थोड़ा सा गर्म हो जाता है. So it can produce heat, it can produce light, motion. Okay, coming to the next part, electric charge. Electric charge मैंने बोल दिया, it's the quantity of electricity. And electric current. Current means how many electrons. The flow of charge or the flow of electrons is known as electric current. Okay, so these were the basics. Now there are many other basics also. Potential difference. Okay, so if there is a difference in two, if the potential at two different points of an electric circuit is different, तो उसमें आप उसको बोलते हैं potential difference. Okay, so these are the basics which you can just revise using your 9-10th physics. Okay, one more thing which can come across this is current बहुत easily flow होगा क्या इसके अंदर? नहीं, ये बहुत easily नहीं flow हो सकता है इसके अंदर. There is something known as resistance, है ना. कुछ नेगेटिव पीपल होते हैं जो आप कितना भी आपको उनको समझा लो, वो आपको पुल बैक करते रहेंगे. सेम थिंग होता है करंट के साथ भी. वो फ्रीली फ्लो होने की कोशिश करता है, लेकिन देयर आर सम थिंग्स व्हिच पुल व्हिच don't doesn't allow it to flow easily, and that mastermind is known as resistance. Okay, and resistance is there in every conductor, and it is measured in ohms. And with respect to that, we have an Ohm's law. Ohm's law is V is equal to IR. Okay, fine. So this Ohm's law, I'm sure everybody is very familiar with, and we have to use this in, I don't know how many, I mean, in many places we have to use this Ohm's law. Okay, so don't forget this. It's one of the most important things in this thing as well. Okay, now coming to the next part, sources of electric power. जो अभी आपने पहले वाला देखा ना, इसमें source के बिना current नहीं चलेगा, right? I mean, the circuit won't work until and unless there is no source, battery, cell, जो भी है. So what are the types of sources in electronics? So sources of electric power, there are two types, AC sources and DC sources. Okay, so what is AC sources? They are alternators or oscillators and signal generators. Alternators means what? It will alternate. Alternate मतलब क्या? एक छोड़ के एक. Okay, so वो कैसे signal produce करेगा? Alternate signal मतलब कैसा? Positive, negative, positive, negative. तो alternate हुआ ना ये? Positive एक छोड़ के फिर से positive, एक छोड़ के फिर से positive आएगा, and so on. So this is alternator. ये है x axis, ठीक है, और ये है y axis. तो origin के ऊपर जो है वो positive हुआ, origin के नीचे जो है negative हुआ. So these are alternators. It produces voltage which reverses between positive and negative polarities. Okay, it varies in times. Fine. So basically AC sources ऐसे ही करता है, जो alternate. AC का full form क्या है, by the way? We have seen in AC fundamentals, alternating current. Fine. So alternator is a machine which is used for producing alternating current. Fine. तो इसमें क्या है, एक shaft है और sinusoidal voltage is generated across its terminals. Power stations में वगैरह use होता है alternators. Okay. Next is oscillators. This oscillator, it converts the direct power into alternating power. जो ऐसे alternating नहीं है, जो एक ही polarity में घूम रहा है, उसको ये oscillator क्या करता है, उसको AC में convert करता है. That is an oscillator basically. And signal generators, if you've used electronics labs, your signal generator can produce various types of AC signals. Okay, it can be triangle. Signal generator नाम ही क्या है? It will generate signals which are AC. So ऐसा shape का हो सकता है sawtooth और triangular shape. Sinusoidal हो सकता है. Okay, then square हो सकता है. ऐसे हो सकता है, any type. It is signal generator, but provided it is in AC, alternating, positive, negative, positive, negative. Okay, coming to next is DC sources. Okay, so what are DC sources? DC sources, as I said, it will produce only one polarity. Fine. So DC sources, what are the examples? Batteries, DC generators and all. Flow of charges in this case is only in one direction. Okay, इसीलिए उसको बोलते हैं DC. ठीक है. So what is battery? Battery is a group of cell. ठीक है, हमेशा याद रखना, cell is only this much. Battery is a collection of cells. एक दो तीन battery cells को मैंने connect किया तो बन जाता है battery. ठीक है, examples nickel cadmium cell है, lead sulfuric cell है. There are many types of cells. आप टॉर्च में यूज करते हो, है ना, वो प्राइमरी टाइप का, एक बार यूज कर लेते हो फेंक देते हो, प्राइमरी टाइप है. वो जो सोलर सेल है जो आप वापस रिचार्ज कर सकते हो, दैट इज नोन एज अ सेकेंडरी सेल. ओके, नाउ a DC generator is again a type of it's similar to alternators, but it will generate it has got a shaft and all, but it gives higher voltage and power than a battery. Okay, and it has a specific speed also, and it will generate DC signals. Rectifiers, very important topic, but it's covered in class 12. ओके, व्हाट डज इट डू? ऐसा एक डिवाइस है जो ऑल्टरनेटिंग करंट है उसको डीसी करंट में कन्वर्ट करता है, जो ऑल्टरनेटिंग है उसको एक पोलैरिटी में लाता है, दैट इज नोन एज अ रेक्टिफायर. Okay, all these sources, no, all these sources, whether it is AC or DC, it will have internal impedance. It will have something known as internal impedance. Whether it is AC or DC, it will have internal impedance. Okay, so for example, if your circuit, I will just draw it. If your circuit has just got a load and a source, मैंने अभी लिया है एसी, एसी है तो आपको सिंबल बनाना पड़ता है एसी, ठीक है, एंड माय लोड इज ऑफ 0.5 ओम. ओके, दिस इज नॉट द इक्विवेलेंट सर्किट. ये जो सोर्स है इसके अंदर इसका इंटरनल इंपिडेंस होता है, तो इक्विवेलेंट सर्किट क्या बनेगा? सोर्स फिर उसका इंटरनल इंपिडेंस एंड देन लोड. सो इंटरनल इंपिडेंस कैन बी से 0.15 ओम. Okay, and your load will be 0.5. So total resistance क्या होगा? ये दोनों series में है, if you can see they are in series, so it will be 0.15. Total resistance will become 0.15 plus 0.5. Okay, so it will be 0.65. So internal impedance is one category which you will see in many numericals as well. Okay, coming to the next part, DC voltage source. Like we saw DC sources, AC sources, there are two. We are going a little bit deep into DC source, DC voltage source and DC current source. No, ideally, okay, ideally, क्या होना चाहिए? A voltage source must have zero internal impedance, है ना? मुझे ऐसा कोई बैटरी चाहिए कि ऑलरेडी सिस्टम में रेजिस्टेंस है, मुझे ऐसा मैं सोर्स लाऊंगी कि उसका भी मैं रेजिस्टेंस संभालू? नहीं. सो आइडियली इंटरनल रेजिस्टेंस जो है जीरो होना चाहिए. दैट सच अ वोल्टेज सोर्स व्हिच हैज गॉट जीरो सोर्स रेजिस्टेंस और इंटरनल रेजिस्टेंस इज नोन एज एन आइडियल वोल्टेज सोर्स. कैन यू टेल मी, कैन यू गेस, ऐसा कोई वोल्टेज सोर्स अवेलेबल होगा क्या? नो, it does not exist. Okay, practically every source has got an internal resistance RS. Okay, so if there is internal impedance, so here you can see that in an ideal voltage source there is no RS, that is internal source resistance. So there is no RS is equal to 0, there is no source resistance. We would all want such a source, right, voltage source, but that is not practically possible. A practical voltage source will always have RS, that is source resistance. Okay, so it's typically less, it's less, but it is there. Okay, now what will happen if there is no because there is no internal resistance, your graph of, I'll take another color because this is not visible, your graph of V source voltage versus load current, okay, will be something like this. It is constant. Why? Because there is no resistance to interfere with, isn't it? Okay, I'm talking about only this much part. I'm not taking this into consideration. Okay, so this much part only. But that's not possible. Once in the practical scenario, when there is internal resistance coming into picture, since V is inversely proportional to I hope you know that. Okay, V is inversely proportional to I, right? Because V is equal to IR. If I take I to the other side, it becomes V by I is equal to a constant, that is R. So that is resistance also. Okay, so practically that the graph will be like this. Okay, so because it's inversely proportional, graph will practically be like this. Similarly, if I take an example of a constant current source, a constant current source is represented like this with a in a constant current source as well. It is considered to be ideal. What is considered to be ideal? If you can see that infinite internal impedance is considered to be ideal. Fine. So in voltage source, what was the scenario? Zero internal resistance. And over here in a constant current source, in parallel, if you can see, in parallel, there should be infinite internal impedance. Fine, that is considered to be ideal. But is that possible? No, it's not possible. Hence, you will always have an internal resistance, that's RP, because it's connected in parallel. It is RP. It will always exist. Okay, an ideal current source does not exist because any current cannot supply constant current. Any source cannot constantly supply constant current, even if its terminals are open circuit. ये open रहा तो भी कोई ऐसा source है क्या जो continuously constant current provide कर सकता है? नहीं. So it does not exist. Okay, how is it represented? It is represented with an arrow. Direction of the arrow determines the direction of the current flow as well. Fine. So this was about the this is the ideal current source and this is a practical current source. Okay. You can in the textbook there is a part where the derivation is there of load current. You can refer that, but in this particular thing I am giving more importance to the Kirchhoff's laws and the other network theorems. That is why I am skipping that part. Okay, so we'll go to the next part. You would wonder where these constant current sources, so what are the examples? A field effect transistor, FET, if we have already done about FET. FET is an example of a constant current source. A transistor in common base mode is also a constant current source for that matter. Okay, coming to the next point, power. What is power? Again, I told you we are all working on basics: electric circuit, electric charge, current, everything. Now this is electric power. What is power? Power of a signal means the rate of doing work. Okay, so the rate of doing work is known as power and it is measured in watts. I hope you know that. You must have done this also before in in science. Now this is very important, horsepower. This can be asked in various MCQs or this horsepower. So this is something you need to remember. The unit is watt or watt, and 1 horsepower is 746 watts. Okay, so it's very there are many things which are measured in horsepower, right? So how much is 1 horsepower? It is 746 watts. Okay. Like I said, you need to remember the definition, the unit, and how much 1 horsepower is. So power, horsepower basically is determining how much power, for example, a car. Okay, you can how powerful a car is these days, that if you go to see the different, how powerful a car is, it's if you compare its horsepower, you'll get the idea. Okay, so this is a small comparison of all the powerful cars I have got, and as you said, its engine power is determined by the horsepower of a car. Okay, so you can relate power to that particular aspect. Coming to the next most important part of the chapter, this is what I wanted to highlight, is network theorems. The most thing, kids, this you will have to use if you're planning to take up engineering in future. This is something you will need in future. So the most important part, that is network theorems. There are many theorems, out of which the first laws which you have to learn are the Kirchhoff's laws. Okay, this is very, very important. It depends, many calculations in network theory. There's a complete different aspect in electronics, or different subject as network theory. Many networks have been analyzed by these laws. Okay, out of which there are 2 laws: Kirchhoff's current law, which is known as KCL, and Kirchhoff's voltage law, which is KVL. Okay, so we will start with KCL first. Okay, so like I said, Kirchhoff's laws can be used to solve any circuit. because they do not depend on any series or parallel connections. Okay, they just depend on two things, current and voltage. Okay, so the first one is KCL. So how will it be asked in the exam? They will tell you to state the theorem, to state the law, and then you have to explain it by giving an example, drawing this diagram and giving an example as well. Okay, and you have to write the sign conventions also. So what is current law? Kirchhoff's current law. Simple सी बात है, जितने लोग अंदर आएंगे हॉल के उतने लोग मेरे घर से बाहर भी जाएंगे. ठीक है, सिंपल लॉ, सिंपल फंडा है. टोटल करंट, ठीक है, जितने एक नोड है, यू हैव टू अंडरस्टैंड व्हाट अ नोड इज फर्स्ट. आई एम सॉरी. ओके, दिस इज अ नोड. Okay, a place where currents come and go is known as a node. So the total the total amount of current flowing towards the node is equal to the total current flowing away from the node. Okay, so incoming current is always equal to outgoing current. That is what Kirchhoff's current law says. Okay, now if you want to rearrange this, इसको थोड़ा सा rearrange करके और भी तरीके से बोल सकते हैं that the sum of all the currents is 0. So algebraic sum of all the currents entering and leaving, दोनों को मिला के entering and leaving in a circuit must be equal to 0. वो भी वैसे भी बोल सकते हैं because मैं out को इधर लेके आ जाती हूँ. So in minus out is equal to 0. That means incoming or outgoing currents in a circuit must be equal to 0. So there are two ways you can say it. Okay, you can write it that incoming currents is equal to outgoing currents in a circuit, or you can say at the algebraic sum of all the currents entering or leaving in a particular node in a particular circuit, that should be equal to 0. Okay, so we will take a quick what you can say example. This is my node, and as you can see, I1 is entering. So one thing according to KCL is sum of all the currents is equal to 0. ठीक है, तो इनकमिंग भी करंट होंगे एक नोड में, आउटगोइंग भी करंट होंगे. तो साइन कन्वेंशन क्या है? जो इनकमिंग है, जो मेरे पास आ रहे हैं, मेरे मदद के लिए आ रहे हैं, right? Therefore, incoming currents are considered to be positive sign. Outgoing currents मेरे से जा रहे हैं, मेरे से दूर जा रहे हैं, इसीलिए they are considered to be negative. So you will put a negative sign. Okay, so we will clear all the drawings. We will analyze this node. What is there? I1 is coming into the node. Okay, so I will write I1. I1 is written already. I need not write again. I1 is written. Next, I2 is also incoming. Incoming means plus I2, correct. Next, I3 देखो, it is going out of the node. Outgoing है. Outgoing को मैंने क्या बोला था? You will give a negative side, therefore minus I3. Next, I4 is also going out of the node. Outgoing, hence again minus I4, minus आ गया. Last, I5 is again going out of the node again, therefore it is minus I5. Sabka equal to 0. Okay, so you can either differentiate it or just keep it like that. It's up to you. It's according to the numerical which is given. Okay, तो इसमें से maybe I1, I2 दिया होगा या I3, I4 दिया होगा. आपको I5 find करना है. ऐसे multiple आपको equation से solve करके you have to find the currents. Okay, so what is the Kirchhoff's law? Algebraic sum of the currents entering and leaving any junction point in a particular circuit must be 0. What is the sign convention? All the currents that are entering the coming towards the node, it is positive. All the currents that are going away from the node are negative. Okay, so this is as easy as it. Fine. Going to the next law, that is Kirchhoff's voltage law. Okay, Kirchhoff's voltage law. Here it is. Fine. Now, don't look at the theory which is written. Just listen to me first. First you listen, then you can take a screenshot and keep reading. Now, what does KVL say? KVL says that the algebraic sum of all of the voltages ये क्लोज्ड लूप है, मानते हो आप? ये क्लोज्ड लूप है जहां पे मेरा एरो है, या दिस इज अ क्लोज्ड लूप. The sum of all the voltages in this particular closed loop is equal to 0. चाहे वो रेजिस्टेंस का वोल्टेज ड्रॉप हो या फिर ईएमएफ हो या फिर बैटरी हो, जितने भी वोल्टेजेस हैं, हाउ मेनी एवर वोल्टेजेस यू गेट, okay, the sum of all the voltages in a closed loop is equal to 0. Okay, now first thing you have to do in this KVL is whenever you analyze a circuit, first thing you will do is try to draw the current direction. Okay, always consider, you can take any current direction according to conventional current or electronic current. I will tell you a thing to remember. Always start with the positive terminal. लंबा वाला positive रहता है, छोटा वाला negative रहता है. ठीक है? Start with the positive. Positive से current जाएगा. So you will put an arrow of the current like this. Start with this. E means EMF. That means the main battery. Okay. Current will start flowing through this resistance. Whenever current is flowing through any resistance, V is equal to IR. There will be a voltage drop. Okay, so this is VR, this is the resistance R, so I will write VR. Okay, it is supposedly the internal resistance, that is why it is R. Again the current will go like this, it will go. Now it is coming across R1, so what will be the voltage drop across it? It will be V1. Okay, again it will come, it is coming across R2. What will be the voltage drop? V2, and then it will close the loop over here. Okay, fine. So this is the clockwise direction I have taken. Okay, तो एक बार ये हो गया, मैंने करंट डायरेक्शन सब मार्क कर दिया क्लोज लूप में. चलो अगला काम क्या है? अगला काम आपका ये है कि प्लस माइनस लगाओ. ठीक है, नाउ प्लस माइनस कैसे लगाएंगे? व्हेनेवर करंट, आपने जो करंट लूप में ट्रेस किया है, in any component, when the current is incoming, that particular terminal will be positive. Wherever it is outgoing, that terminal of the component will be negative. ठीक है, फाइन. क्यों हमको सबका EMF, सब वोल्टेज ड्रॉप काउंट करना है, इसके लिए प्लस माइनस करना है हमें. ठीक है, so voltage drop, wherever the current is entering, that section or that part, that terminal will be positive. Wherever it is leaving, it will be negative. Okay, so my positive of the battery is over here, my current starts flowing from here. Okay, leave हो गया. Okay, यहाँ से leave हो गया. So first component which is entering is what is the first component which is entering? That is positive, right? So that will be positive. EMF को तो आप कुछ नहीं करोगे क्योंकि EMF को ऑलरेडी साइन है ना. लंबा वाला डंडा पॉजिटिव होता है, छोटा वाला डंडा क्या होता है? नेगेटिव होता है. तो उसको तो आप कुछ नहीं कर सकते. ठीक है, you will not do anything to the EMF बेचारा. EMF को ना हम एक काम करते हैं, we will put it in a different color so that we get to we know that we are not supposed to touch the sign conventions of the battery. पता चला बैटरी को ये कर दिया हमने. You cannot touch the battery. So this is plus, and negative, छोटा वाले डंडे को it is negative. Okay, so you will not touch that. चलो, let's start tracing. Entering the resistance, plus terminal. Leaving the resistance, minus terminal. चलो, the current will go from here. चलो, entering R1, this terminal will be plus. Leaving the terminal, this terminal will be minus. चलो, आगे. Entering R2, this will be plus. Leaving R2, this will be minus. And back to the EMF. Okay, will you consider entering and leaving of EMF? No, you will not do that. It already has its terminals plus minus. Okay, so please don't consider the battery. Never consider the battery. Fine. Now you have to apply KVL. Now you have to take the sum of all the voltage drops. Okay, starting now. What you have to understand is, जैसे तुम लोगों ने trace किया, as you traced the current, you write the same signature also. I mean the same sign for that. Now my current is entering E. What is the sign I see over here? Minus. So it will become minus E. Okay, minus E. Current वापस जा रहा है. कहां से एंटर कर रहा है, कौन सा टर्मिनल आया पहले, प्लस, सो इट विल बी प्लस VR। ओके, जा रहा है जा रहा है जा रहा है जा रहा है जा रहा है, R1 आ गया, कौन सा टर्मिनल आया पहले, प्लस आया या नेगेटिव आया, प्लस, सो इट विल बी प्लस V1। जा रहा है जा रहा है जा रहा है, रेजिस्टेंस का वापस R2 आया, कौन सा टर्मिनल पहले आया, प्लस आया या माइनस आया, प्लस आया, इसलिए प्लस V2 इक्वल टू 0। And then you can solve very easily. Okay, so this is all about KVL or Kirchhoff's voltage law. Okay, let us solve one problem. Okay, here you have to write an equation applying KVL. Okay, chalo, let us do that. This is the EMF and the source is named V4. No problem. चलो, इधर प्लस माइनस ऑलरेडी बैटरी को ऑलरेडी प्लस माइनस दिया रहता है, you are not going to change that. My current will start flowing from the plus direction. It will go. Oops, I found a resistor. चलो, entering position will be plus, leaving position will be minus. Go. Oops, another resistance. Entering position will be plus, leaving terminal will be minus. Go. Again resistance आ गया. Entering terminal will be plus, leaving terminal will be minus. Go and back to the EMF. Come on, let's write the formulae. Okay. I wish to start with V1. I don't want to start with the source. I want to start with V1. No problem. Chalo. When the current is entering, which terminal is it entering? Is it entering the plus or the minus sign? It is entering the plus. So this will be V1. I can write a small plus here. Next, V2. Which terminal is the current entering? Positive or negative? Positive. So this will be plus V2. Current is going through this, entering V3. V3 में कौन से terminal में enter हो रहा है? Positive में enter हो रहा है या negative में enter हो रहा है? Positive में enter हो रहा है. So this will be plus V3. यहाँ पे करंट जा रहा है, यहाँ पे एंट्री हो रहा है, किस में एंटर हो रहा है, पॉजिटिव में एंटर हो रहा है या नेगेटिव टर्मिनल में एंटर हो रहा है, नेगेटिव टर्मिनल में एंटर हो रहा है. सो दिस इज माइनस V4. और कोई है क्या कंपोनेंट? नहीं, वापस V1 में क्या, हमने V1 तो ऑलरेडी ले लिया है, इज इक्वल टू 0. ओके, इफ आई वांट टू रीअरेंज दिस अ लिटिल बिट, I will take minus common. I will take V4 to the other side. It will be V4 is equal to V1 plus V2 plus V3. Okay, so this is you can write in the bracket by applying KVL. Okay, so this was all about the KVL and how to solve it. Please try and solve the easy numericals which are there on page number 15 also. Try to solve it, and if you have any doubts, please let me know in the comment section. And this is very important, so please, it's very interesting also, right? So do whatever you can do, and please solve more and more numericals. Okay, thank you, have a great day.